Welcome to another episode of Matrickz Tech Talk. Today, I have Tom Jellicoe, all the way from London, a Cambridge PhD in physics, who's running the autonomous driving team in TTP PLC. Tom, welcome to Matrickz Tech Talk.
Thank you. Yeah, it's a great honor to be here.
So I'm really excited to have a conversation with Tom. Tom, why don't you tell our audience a little bit about yourself, your background, your passion?
So by background, I'm a scientist. I've got quite a broad background and training. So I started actually as a chemist working on functional materials research. So we were kind of working on new material sets that could be functionalized so that they'd be useful for various different things. I think I really enjoyed the elements of research and solving scientific problems, but I guess my passion really is working on challenges that are going to affect the real world in a way that I can measure myself. So at the conclusion of my master's, I actually switched to physics, and I did a PhD in solar energy. So I guess it's getting a bit more applied and a bit closer to industry. In that research, we were kind of looking at ways you can use high energy light to extract a little bit of extra current out of solar cells. It was really rewarding and I learned a lot, but still I think in the solar energy industry and my experience there, I think a lot of the challenges now are not really about the physics anymore or the science. I think a lot of it's around kind of business model innovation and infrastructure. So kind of left the academic world after a postdoc. I went and worked for a scientific instrumentation company that were really commercializing kind of scientific breakthroughs to make tools for researchers. And then from there, I found my way to TTP. So TTP is Europe's largest independent deep tech consultancy. We invent, design, develop new technologies for our clients to integrate into their products. So we kind of find areas where there are big technology challenges that require scientific understanding and development to really crack them. And then we work on those on behalf of our clients to solve their problems. So when I started at TTP, I initially kind of bounced around between different teams. I did some time in the life sciences industry, working on diagnostics for flu. I worked on some projects in the energy industry. After a while, I was kind of given the opportunity to look for new areas where TTP might be able to leverage some of its skills. So I guess what I was looking for were areas where there was real kind of development of technologies, not just kind of business model innovation, not just integration of existing technologies, but really fundamental technology innovation at its core. And I guess that's kind of what led me towards autonomous driving. It wasn't an entirely new area for TTP. I mean, our first project in that space was, I think, 2003, looking at computer vision for one of the OEMs for road sign recognition. So, there was significant background within the company, but it's been kind of patchy over time. I think as a technology consultancy, it's quite challenging to work with the automotive industry, I guess probably pre 2015, 16. The automotive industry is very cost constrained. They're used to integrating very well developed and well understood technologies into their products, right? If you think about how long you could get a smartphone for before touchscreens were available in cars, it's an industry that wasn't always at the forefront of technology innovation, but was much more of a technology integrator. I think, the rise of autonomous vehicles has really changed that dynamic, particularly the entrance of tech companies into the space. So it's now looking like quite an interesting place to play for a technology consultancy like TTP. Where we've found our real focus is very much on the sensors and the actual core sensor technologies for autonomy. We've got great skills in optics, in integration, in micromechanism design. So it really fits nicely with some of the challenges that autonomy companies are facing. I now have the best job in the world, which is going out and talking to technology companies about what their really valuable challenges are, and then working with my team in Cambridge to ideate and come up with solutions. And I'll be happy to talk about some of the challenges that we've identified today, because I think they're really fascinating.
Amazing. Tom, you have identified several stimulating issues. So you mentioned that why were we slow compared to traditional IT industry, or what other technological advancements, and what is driving us now that it's kind of like as if there has been a catalytic effect due to AV in the market space. Can you touch base on that a little bit before going to the core technology that you work with?
Yeah, I should preface my answer by saying I'm by no means an expert analyst on the automotive industry. I think my experience is kind of limited to our work in this space, and at least my work in this space over the past few years. But I think when you look at the structure of the industry, it's very stratified, right? What we find at TTP has worked for us for the last 30-something years is kind of working on challenging technology development requires really intimate, multidisciplinary collaboration, and also very close collaboration with different companies with different skill sets. When you look at the structure of the automotive industry, it's very rigid. You have the OEMs at the top who, control the relationship with consumers. They design their cars and they integrate all of the parts. You then have their tier one suppliers who are buying components, integrating those into automotive qualified packages, which the OEMs can buy. And then you have the tier two suppliers who are, supplying the components, so on and so forth. All of these layers are kind of squeezing each other for margin. It makes sense that taking on huge amounts of technical risk in that sort of environment is kind of undesirable and probably not a great business decision, right? It means that you're limited to quite developed technologies from other fields, where a lot of that early stage development and spend has taken place. So a lot of the rough edges have been knocked off them already. Cars, quality is so important. So, bringing a new technology up to automotive quality standards remains a real challenge. So I think that kind of the stratification of the industry has always made the integration of new technologies quite challenging. I think what's changed now is effectively the entrance of Silicon Valley and the Silicon Valley approach to many of the tech challenges. There's a number of very large companies now in Silicon Valley who have challenged a lot of the assumptions of the automotive industry, and it's really changing it at quite a rapid pace. Far faster than it's changed, I think, in its history.
So before we begin, you wanted to talk about the challenges. Before you even go to the challenges, can you talk a little bit about what kind of a sensor system that you're developing and how does it help your client in the AV space or even ADAS space?
Sure, yeah. I think, it's really interesting to note the two opposing business models between AV and ADAS. Both represent kind of very separate and very different groups of companies taking very different approaches. But one might assume that eventually these two approaches do need to converge. I think when you look at kind of where autonomous driving started and where it's come to, I think it's difficult to gloss over the DARPA challenge and the results of that, that kind of, I guess, seeded a lot of the interest on the West Coast in autonomous driving. The main challenge here is we're trying to replace a human driver with a machine. Humans have been evolving for many millions of years to develop kind of systems and kind of effectively biological hardware required for a highly optimized system for perception planning, all of the sort of individual components we're trying to replace in an autonomous vehicle. The compute of a human brain is almost perfectly designed for those specific challenges. When you first try and achieve a technology goal, the initial approach is kind of throw technologies, throw kind of resource at it until you can hit the performance spec. And then afterwards, you can refine that down afterwards. What this means in autonomous driving is redundancy, I think, in kind of pretty much every system. So instead of just having two vision sensors like a human can use, you end up with much more functionality. You need many different sensors, all that work in slightly different and contrasting conditions. I think what's rose to prominence is the LiDAR sensor. That's actually where we tend to spend a lot of our time looking is, ways to improve LiDARs to hit the requirements of OEMs and AV customers. I know it's a slightly controversial topic. There seems to be two camps of whether LiDAR really necessary. I think on one side you have Elon Musk, and on the other side, kind of most other people. I don't have a particularly strong opinion on that because I tend to be focused more on the sensor suite. But LiDAR itself is a really fascinating kind of technology platform on which to work. When you look at the diversity of technologies in LiDAR sensor, it's kind of mind-boggling. I mean, when you look at the automotive industry and the supply chain for cars, for each part, you might have 5 to maybe 15 suppliers globally that produce kind of 95% of the components. And then in LiDAR, this kind of key sensor to autonomy, you've got, at one point, I think analysts were predicting more than 100 companies. I think that's kind of consolidated down a bit now. But, there's been enormous investment. And I guess what I find really fascinating about it is every single company seems to have a slightly different approach. It's not just kind of the diversity of companies, it's, the diversity of science and technology which are in each of these sensors. Some are solid state, some are scanning, you have flash LiDARs, you have mechanical spinning LiDARs, just about every possible architecture. I think it's really interesting now that we're starting to see consolidation down to a few kind of core platforms. And I guess this is probably being driven by a much better understanding of what the key use cases are. What we're seeing with the LiDAR companies now is the companies that seem to be on top are those that have a really credible path to series production. These companies typically have raised in the order of $100 to few $100 million to develop their sensor. In order to justify that outlay, there has to be huge revenue and upside on the other side. I don't think you get there just by selling kind of thousands of sensors to AV companies and waiting for that market to mature. You really need to have a credible route to series production. What that means is not just kind of a roadmap, but you need to have your destiny fully within your hands. Your success can't rely on, one key supplier successfully scaling their technology. And I think that's kind of some of the challenges that we're trying to address now, is helping companies who might not have all of the pieces of the puzzle to fill in that gap so that they can own not only their system design, but the key component designs within it and how it all works together, and really hold on to that IP so that they can then be a competitive automotive product.
So you mentioned a very interesting phenomena that we have hundreds of, maybe not hundreds, more than 100 LiDAR companies, when, this is not a typical scenario in automotive component manufacturing. What was the reason, you think? Why so many aspects? And they're all sort of unique from their own way, as you mentioned, and I agree. And what was the reason? There was like, this is a technology that we have. Is it just because we had a lot of room for imagination or innovation, or is it like it's not optimal enough? Is it really there are a lot to be explored yet?
I think one of the reasons LiDAR is so interesting is that it's kind of, there's so many parts to a LiDAR sensor, and developing each one is difficult. If you think you have your laser driver, you then have to direct your light around the scene. So you have some sort of beam steering system. Then you've got your receiver, which has to be ultra precise because you're really pushing the limits of signal to noise. And then you have all of your control electronics and your algorithms. Each one of these is a really big technology challenge with quite a large solution space. If you then combine all of these into a single product, then suddenly you're in like 4-dimensional solution space that covers this enormous range of possible architectures and possible approaches. So I think that sets a fundamental limit on, how many approaches you can take to solve the LiDAR problem, if you like. I think also there was a certain amount of hype around LiDAR as well. Quite a few years ago, there was a lot of venture capital flying into it. There were a lot of very favorable valuations. I guess that probably peaked around 2018. There was tons of companies founded up to that point, loads of deals, really big valuations. I think what we're seeing now is a bit more of a pragmatic understanding of LiDAR. of the challenges that it has to face and the value of those challenges. And this is leading to kind of consolidation, fewer new companies being founded, but really still very substantial rounds being raised by the leaders in that space. Starting from such a diverse range of solutions is probably not a bad thing, because it kind of means that a lot of things have been mapped out and there's a lot of understanding gained from that. And these are now sort of starting to filter down into a few kind of key technologies. If you track it on a hype cycle, I think we were at the peak of inflated expectations maybe a couple of years ago now. And I think it's probably bottomed out and we're really starting to see the slope of enlightenment, I think is called, particularly with the activity. There's been a couple of very large exits for LiDAR companies in the last kind of 3 months or so. So yeah, I think it's a really exciting industry now. There's not tons of new companies being founded, but now we're really starting to get into the nitty-gritty challenges, what it means to get a LiDAR into a series production vehicle. I think the core, initially the focus was getting the sensors to where they needed to be on their core operation, things like range, resolution, really, really key metrics to make them useful to their customers. I think that's kind of getting there. And now what we're starting to see are challenges around successfully integrating them into vehicles. This actually, physical ease of integration, reducing the size, making them robust to automotive driving conditions, high vibration, enormous temperature ranges, exposed to all elements. Cars have to drive in all weathers around the world. I mean, I live in the UK, so typically we get all weathers in a single day. So that's not an easy challenge to solve. And also because some of the commercial pressures are really starting to take hold now. So I guess really reducing the cost to the sort of price that an OEM can economically pay for it. I think that's a really interesting challenge. If you look at the cost of a luxury vehicle for, I don't know, a few tens of years, inflation adjusted, it's not really changed that much. Over time, the cost of a luxury car is pretty similar relative to, earnings. But each generation, consumers expect the technology to improve. The standard options on, top of the range, BMW, Audi, Mercedes now are very different to what they were 10 years ago and very different to 20 years ago. We expect them to improve over time, but there's this expectation that you don't kind of increase the consumers don't have to pay for that. I guess this is part of why kind of well understood technologies are integrated, because that fits with the cost model. What I think is really interesting about kind of ADAS and autonomous features is they have to be made to the cost point that's acceptable to a consumer. So the cost for the ADAS system is set by consumer expectation rather than the cost of what it takes to make it, and hopefully some margin for the company who makes it. So it's this really, I guess, really fundamental challenge to get down to very low cost points from quite a high starting position. So yeah, I think there's lots of really interesting challenges now in LiDAR. Fortunately, I guess for us, in a lot of cases, there is kind of scientific innovation at the core to the solution.
Totally. I mean, like I said, there was a hype. I mean, all of a sudden there was this idea that LiDAR is going to solve all our problems. That's one piece of the puzzle, the whole puzzle, that we probably will need in order for AV to be real. Now, I want to move a little toward the challenges you mentioned. Tell us about some of those challenges that you see today.
So I guess we learn about these things from both our clients and also from their customers too. So, we have to be, we don't just talk to startups or, tier 2 and tier 1 automotive companies. We talk to OEMs, we talk to analysts, we talk to everyone to really try and bottom out where the value is. One of these conversations, maybe that started kind of 4 years ago with actually some tier 1s and some OEMs, was around sensor cleaning and the challenge of keeping sensors so that they're 100% available to the vehicle. When it's just your reverse parking camera, this is less of a challenge because, the vehicle can effectively operate without it because of the human driver. And, it's not so unacceptable to go and clean the sensor every so often. Once you go to expensive autonomous features in a vehicle or a fully autonomous vehicle, then this becomes, it's a critical system for the operation of the vehicle. They need to be available at all times. That makes it a much more interesting challenge. If you go back to the analogy of replacing the human driver, if you're driving your car and, I don't know, a bird takes a massive dump on your windshield, what's the first thing you do as a human driver? So most people will just move their head, right? They just kind of look around it, and then they'll get their liquid jets and they'll get their wipers, they'll clear it, their view's not obscured anymore, and they can carry on. But they've got this kind of intermediate solution. They can shift, they can adapt. When you've got fixed sensors on an autonomous vehicle, this is not possible. I mean, the sensors are highly calibrated. They have an internal calibration and an external calibration. The car needs to know exactly where they're pointed so that it knows where the information is relative to the vehicles. You can't just simply move them out of the way of dirt. When you look at the positioning of the sensors as well, in a lot of cases, they need to be on the exterior of the vehicle. In particular, LiDAR sensors, you can't just stick them behind the windshield like a human driver who has some protection. The LiDAR, most windshields actually have a reflective coating for the infrared region to stop the vehicles heating up too much, so you don't have to use your AC so much on sunny days. Unfortunately, this reflective coating works really well for the laser light that LiDARs typically use. So they need to be integrated to the vehicle exterior. So then you need some way of keeping them clean to ensure that the vehicle is able to operate under all conditions. There's kind of two parts to this, I guess maybe three parts. It's kind of knowing when the sensor needs to be cleaned, cleaning the sensor. And then I guess the other part of the challenge is not so much technical, but it's kind of whose responsibility is it to keep those sensors clean? We've been kind of looking at particularly the first two. When you look at automotive cleaning systems, forever cars have had wipers for the windshield. They're ubiquitous. Everyone's familiar with them. It's a very well understood technology. There are plenty of companies who have been making these things for many tens of years. Liquid jets, similar. You have your wiper fluid. This system works for windscreens. When car headlights got so bright that they needed their own cleaning solution to prevent dazzle, the obvious first point of call is wipers and liquid jets, right? It's a ready-made solution. It works. That's the obvious place to start with sensor cleaning. You start adding additional points on the exterior of the vehicle you need to clean. Start with a solution that works in the past. And that's what a lot of companies have done. And that certainly works in the interim. But I think one of the really big challenges with implementing that kind of long-term, particularly if you want to get to level 4 or level 5 driving, is, as we touched on earlier, it's the redundancy, it's the proliferation of sensors. If you look at the sensor suite that Zoox use, so recent Amazon acquisition, they've got 18 cameras and 8 LiDARs on the outside of their vehicle. It's not feasible to install 18 wipers and liquid jets. It requires too much liquid volume. You need something cleverer. That's true of all AV companies, and it's likely to be true of all level 4 and 5 vehicles. So I guess this was a challenge we were set by the OEMs a few years ago. So we spent some time exploring this solution space and looking at what's available. I guess the behavior you want is clean sensors, but really the challenge is reducing the liquid volume required to do that. You don't want to be replacing the fuel tank in your car with a washer fluid reservoir instead and adding all that mass and complexity and just making it onerous for a vehicle owner to constantly change this. It's really about reducing that liquid volume to an acceptable level so a vehicle can drive and remain safe at all times. I guess you can do this kind of one of two ways. You can either try and prevent dirt from ever getting on the sensor, either by some clever integration or some clever product which redirects it. So I guess it's the most obvious solution, just stop it getting dirty. I think there are several challenges with that. I mean, if you talk to an OEM about the sensor guys, their sensor engineers choosing where the sensors go, then their car designers get very upset. And I think in those kind of discussions, often the car designers will win. So that's quite challenging. I mean, the other thing you can do, maybe put some aerodynamic features so that you can control the airflow, maybe blow across the sensor so that dust's less likely to settle on it. Again, adding lumps and bumps to top spec German car is not going to make you any friends in the design department. So you kind of have to look for other solutions. There are some companies doing really great jobs of reducing the liquid volume by maybe up to 50% for a liquid jetting system, but it doesn't really get you to where it needs to be. I guess the solution that we're most excited about is actually ultrasonic cleaning. So it's integrating kind of new technology into the sensor itself, so that it becomes effectively self-cleaning. This requires much, much less liquid, you just need a wetted surface. And, instead of saving maybe 50% of the liquid, you could be saving 95.
So the challenge you mentioned is clean sensors, be it camera, be it LiDAR, be it whatever kind of sensor, they have to be cleaned. Obviously, we have to optimize cost. And you talked about many, many solutions like, obviously like a wiper, water, airflow, and finally ultrasound. When you talk about this cleaning, sensor cleaning technology, do you work with your clients to give them the solution, or do you also sell products or work for the OEMs for series development?
Yeah, that's a very good question, and I guess almost none of your listeners will have ever heard of TTP before, so it's a very good one to answer. The reason for that is that I guess it was kind of option A of your list there. So we work with our clients to integrate technology into their products. So we've done this for 30-something years. Technology we've developed is in a whole range of household products, but obviously these are then manufactured and marketed by our clients. So it never has our name on it, and we're happy with that. We get to work on the really fun technology challenges at the beginning, and that's what we're best at. So that's why it makes sense. In order to know what the really exciting technologies are, we have to have a really good understanding of what the solution space is so that we can propose these to our clients, and we end up mapping out these things. And I think this is kind of where our interest in sensor cleaning comes from. I guess my job is to find where the valuable challenges are for the industry. We can then develop technologies which our clients can integrate. Sometimes we'll file IP on their behalf, so that, we will actually file patents that are assigned to them. As you can imagine, with large corporates that are typically brilliant at managing product life cycles, owning a product all the way through all phases of it, but not necessarily, innovating rapidly at the front. That's where we tend to help them, coming up with new ideas, finding these new technologies which they can then manufacture at scale profitably. On the other side, we do half our work with startups, typically venture-funded, very, very ambitious startups they're always trying to solve really, really big challenges to a very, very short deadline. And often they'll have brilliant ownership of their core skills and their core IP, but not necessarily the personnel bandwidth or, the headspace to then add additional functionality on that might be slightly outside of that. I think this is kind of a really good example with the ultrasonic cleaning where, you go to a LiDAR startup and they're brilliant at laser physics and they're brilliant at maybe MEMS production for their beam steering technology. Making small parts in silicon is their thing, but not necessarily developing an ultrasound transducer to automotive quality standards that can integrate into their sensor. It's slightly different. So that's where TTP might work with that company to help them do that. And it's a really good fit for TTP. I mean, we've worked on, I think, ultrasonic products for pretty much every industry you could imagine, from kind of consumer white goods all the way out to high-end aerospace devices, printing. So it's kind of a nice fit for us, and we have a really good understanding. At the start of this, we spent quite a long time really understanding what was required to make ultrasonic cleaning successful in a vehicle. There are a number of kind of smaller sub-challenges to address. I guess the first is really understand what the mode of cleaning is. So to give a bit of background, ultrasonic cleaning is used in a variety of industries. Anyone who's ever spent any time in kind of a clean room or a workshop will have probably used ultrasonic baths to clean. In a clean room, you might use it to clean your silicon wafers before you go and put them into a process. even car garages use them to clean their tools and remove the grease from them. This is a pretty well-established cleaning technique. It's used in high-end digital cameras to remove dust from some of the internal components as well. In the case of sensor cleaning, it's a little bit different to immersing something in an ultrasonic bath. You're having to do the cleaning directly on the surface itself. You don't have an additional kind of surrounding to create the environment. It turns out that one of the most effective ways you can use it on a sensor is by atomizing liquid from the surface. So what this is, the way this works is you wet the front surface of it, you shake it, you ultrasonically vibrate it. So you imagine, like a wobble board or something, it resonates. And if you can get the surface to move past a velocity threshold, so if you get it to move fast enough, it can break the surface tension of that liquid. You imagine if it moves quickly enough, it effectively flicks a droplet of liquid off the front surface. If you've just got a small wetting layer on it, it will eject all that liquid, carrying whatever dirt and grime was on the sensor. So this ultrasonic atomization is a technique used in some household products as well. Some room fragrance atomizers use a similar principle, the sorts of things that just sort of sit in the corner of a room and squirt nice smells out every so often. Some of these use a similar principle. It's not an entirely new idea, but it's kind of innovative to use it for this sort of cleaning process.
It's fascinating. You also mentioned the way you help your client meeting the automotive quality standards and so on. And, LiDAR or sensor, clean sensor and safety when it comes to AV setting or ADAS setting is absolutely essential. That's a no-brainer. So tell me a little bit about your thoughts on the safety aspect of sensor cleaning.
Well, I guess it's part of ensuring that a safety critical system is operational, right? The functional safety is important at a system level all the way down to, individual sensor level. I think we tend to work on products from kind of early stage concepts and ideas all the way up to production. A lot of our influence is quite early on in the product development process. I think when you start looking at safety and safety standards and working on new technologies, there's kind of a bit of a challenge and an interplay there. The standards and the new technologies kind of have to talk to each other and inform each other, right? You can't put something in a requirement that doesn't exist yet. You need to know about it. And equally, those two things, those two things need to be kind of working together. What we find, particularly with the early stage technologies, it's not possible to design a technology that, meets all safety standards straight from the start. It's possible to design a technology that will never be useful in a vehicle, will never meet those standards. So it's certainly something we need to be aware of. I think, primarily the sensor cleaning problem is addressing a safety challenge. If the sensors become unavailable, then the only course of action is either in an ADAS feature, it will be to switch that feature off so that, the user loses functionality and doesn't have the benefit of their very nice option package that they paid for in their vehicle. In an AV, it's even more serious. The vehicle can't operate safely, so it would have to stop. It's primarily driven by safety, but I think that's probably true quite, except for the commercial pressures, that's true of a lot of the innovation around sensors.
So to our audience, to the youngsters, what would you suggest? What are the things to look at? What is your structure for solving such something? You were given a challenge, you go to your client. What are the questions to ask? How do you go about it? And how do you research? What's your methodology?
Yeah, so I think the first part of that, which is often an important part of my job, is, I guess, really getting into the details of understanding that challenge, not just the challenge itself, not just reading a functional specification, understanding what drives the information in that, understanding the priorities. And then there's an ideation process to look at how kind of existing technologies might address it, or kind of where tweaks or innovation might help you to come up with a working solution. We're always working with a client on this. So it's for a product, and that client will have a fairly good understanding of what they want from it. What we'll typically then do is bring in a team with various different skill sets and experiences. I guess TTPs who existed for 30 something years in so many different industries. There's a real diversity of experience here. And I guess there's very few technology problems that haven't been solved anywhere else ever in another industry. So often, collaborating and bringing in different disciplines, different approaches, is really valuable way to solve these sorts of challenges. It's one of the ways we really add value to autonomous driving, I think, is bringing in things from defense, aerospace, security. We've worked on technologies for satellites before. We've kind of done a bit of everything. So you can bring in this diversity of experience, and then from that, we'll come up with some concepts. We'll typically model these quite extensively, really understand how they work, at least computationally. Sometimes we'll do some early prototypes, and then we can mark how these work against the criteria, where they're good, where they could be improved. And at that point, once we work these ideas up a little bit more and flesh them out, and they start to look a little bit more like technologies or products, then we can start thinking about what the roadmap is to get these things to market, to get those into a product. And at that point, you can start making kind of return on investment calculations. This is how much value it adds to a product, and this is what it will take to get there. Fortunately, we have a lot of experience in that translation process. I mentioned the hype cycles earlier. There's a lot of guys at TTP who've been doing this a lot longer than me, who have seen many of these different trends come and go, and and bear the experience of that, and have quite realistic expectations of what it takes to get a technology from an idea in a scientist's head to a successful product made at scale economically.
I'm really excited about the diversity aspect that you mentioned. Learning from other domains and bringing the technology in automotive, or the other way around. How many employees do you have in your company?
We've got just under 300 technical staff at TTP, spanning pretty much every discipline of engineering and science you could imagine. And we've got a lot of engineers, everything from algorithms and signal processing, software, lots of mechanical engineers. We've got kind of tons of scientists, lots of physicists. We've got some material scientists and chemists. We do quite a lot of business actually in life sciences and medical technology. So we're increasingly hiring biologists now, which I guess 10 years ago was kind of a brave new world for TTP, but has actually become a really valuable part of our business. So there's kind of a real diversity of experience from many different industries. In the autonomous driving team, we've got a few scientists. We've got some guys with an automotive background, both from conventional or from motorsport. Fortunately, a lot of the world's Formula One teams are located not too far from Cambridge, so it's not too. It's often quite valuable for us to kind of pick a few of those guys out, and they're brilliant at solving really tough engineering challenges for stuff to go on vehicles. We've got, and we also kind of hire some of the best academics available in the country. Our proximity to Cambridge makes us very fortunate that we can pull on a lot of the skills and understanding there. I mean, at the core of all of the work that we do is really understanding of the science and the fundamental engineering of the product or the technology. So being so close to a university of that standard has been really valuable, and is one of the reasons that we're located where we are. We also recruit from all corners of the country, and actually we have quite a lot of international employees as well. So we kind of bring people in from wherever we can find the skills to kind of tackle these sorts of problems.
Amazing. So the diversity factor really helps, and I've seen in companies like 100,000 employees, it is so much siloed even within departments. Forget about disciplines. Yeah, so people have no clue what even the other department is doing. Very often it happens that they're actually solving the same problem, and enormous amount of money is wasted like that. So that is something that is fascinating about your company, that you're actually, with this size, I could imagine this is much more doable than the scale I'm talking about. With that, I'm gonna move a little bit toward safety challenges, in AV, because John Kravchik, the CEO of Waymo, mentioned that expecting AV to be a solution for all situations it's just not realistic. On the other hand, we have enthusiasts like Elon Musk or evangelists like Elon Musk promising things that would solve everything. So what do you think is a realistic expectation, and what are the main challenges to make it safe in terms of, we can narrow the space down to sensors? Yeah.
When you look at conventional passenger vehicles now, there are lots of conditions where people look out the window and think, I'm not going out in my car today. So I think, it's challenges not just on the driver. There are some fundamental limits on that. In heavy snow, vehicles are not safe, and in really icy conditions, that can be problematic, regardless of who's driving the car, whether they're human or it's an autonomous vehicle. So I think that, that's perfectly reasonable. I mean, one of the things that's quite exciting about sensors, some of the sensors that are being developed for AVs is they have functionality which goes beyond what human drivers can do. We use vision sensors that measure light in the optical spectrum. Our eyes have adapted to measure the most abundant light source in the Earth's atmosphere. It turns out in the atmospheric absorption lines, there's this kind of bump, which is effectively the spectral, which gets through to the Earth. So there's lots of light around. That's why we've evolved to use that area of the spectrum. That doesn't mean that other areas of the electromagnetic spectrum, so different wavelengths of light, can't be useful as well, just because we can't access them with the specific absorbers we have in our eyes. So I guess what I'm alluding to here is that actually there's lots of sensors which have additional functionality that humans could never have. I'm thinking, I know one of your guests on a previous podcast was Jakob from Adasky. Thermal imaging, it's not something humans can do, but it's so much more resistant to certain forms of weather that we can't see. When there's weather which scatters visible light very strongly, so I guess mist, fog, rain, things that kind of generally look white to us because they just scatter all of the light the spectral ranges that we see back at us. That's not necessarily true for other spectral ranges. There's kind of a whole bunch of technologies that kind of start at the limit of where the eye can see and move right out into the infrared. From shortwave infrared all the way to longwave infrared that all have different functionalities which can be more resistant to certain weathers than we can. There's also clever tricks you can play with how you measure your signal to effectively filter out some of the backscattered light that you don't want. When you're looking into fog and you just see white, the problem there is that loads of the light is just being scattered off those particles straight back into your eye. So it's kind of, literally clouding your vision, but getting in the way of the signals that you actually want, probably the rays of light from much further objects. If you can use clever things with timing electronics on your image sensor, you can select different depths and you can see through things like mist and fog. There's a really exciting Israeli startup, Rightway Vision, who are doing just this. There's lots of possibilities for things that go beyond human perception that might make it possible for autonomous vehicles to operate in conditions where humans can't. I think that's one of the exciting parts of autonomous driving. This redundancy of sensors and redundancy of approaches means that there's kind of additional functionality that human drivers can't do. We don't have the full sensor suite of an autonomous vehicle, and even though we've got this optimized compute in our brain, we don't have all the information coming in to make decisions under all circumstances. But maybe an AV will do one day.
So we're talking about the environment now. Well, the traditional safety in automotive has been within the vehicle. So what goes wrong in the vehicle? But when it comes to the environment, there's no way you can know everything. And when there is an unknown, there's no way you can take a measure for that unknown. So in AV safety, that unknown is a big problem. Although your sensor will have capacity to see something or sense something beyond human capability, but there will always be unknowns that we have to deal with, which conversely, a human, although we have limited senses, we're better in dealing with situations which are totally unknown. How do you think we'll balance that out?
I guess the key way to address the challenge of kind of unknowns is to record better data. And I guess in particular, have better understanding of the limitations of your recordings. It's not just good enough to measure something really accurately, it's to know whether there's systematic errors, what the shortcomings are, really understand what the limitations of certain sensors are, so that we can better understand. I guess we can go down the rabbit hole of known unknowns and unknown unknowns. But the better you understand your sensor, the better you can make that call. I think the way we're seeing that play out in AV is that, interestingly, one might imagine in a conventional automotive model that, you have an OEM producing a vehicle, maybe one of their tier ones produces like the central ECU and control algorithms. And then you have sensor providers who provide effectively commodity sensors that kind of are integrated onto the exterior of the vehicle. So actually a lot of the value of that system is in the core kind of ECU and the algorithms which sit within that. And you have effectively these kind of dumb sensors just sending in data. It turns out that actually that's quite challenging with the sensor suite on an AV, because each sensor has, you really need to understand exactly how a sensor works to know when you can and can't trust the data from it, and how much you can. So I think what we're seeing is, a lot of companies that might have just been pure sensor manufacturers are actually doing a lot of work on the algorithms themselves to really tackle these sorts of problems. So, no one knows how to use their data better than the person who designed the sensor that produces it, right? They understand their sensors intimately. They understand when they work well and when they don't. So they're best placed to produce these algorithms. So you end up with this kind of late fusion architecture where actually a significant part of the stack is actually owned by the sensors, maybe a larger portion than you might have first predicted. You've seen some of the LiDAR companies, for instance, they've got hundreds of really great software engineers now. And you'd think, these companies were probably founded on some sort of laser physics or some cool silicon mirror technology or something like that. And suddenly now they've actually got really significant software presence because it's so important to have intimate understanding of the sensor in order to know what to do with the data that comes off it. Of course, this takes time. An AV has to operate under all conditions, not just the conditions it wants to. So then we end up in this problem of edge cases. You can't just conveniently ignore them because you don't like how they work. You have to find a system that's robust to all of them. And, to bottom all of these things out takes time, and it takes effort, and it takes really great engineering and innovation. But, that's kind of the way things are going. I think to really get into that, at the core, it's understanding of the sensor technology. I think that was one of the things that we really recognized, that there's so much value there that's why we've kind of positioned ourselves at, this kind of fundamental level. We work with the fundamentals of the sensor rather than just kind of optimizing, because that's the key to actually making a robust system.
Totally agree with you. So your remark on sensor companies now becoming a software company, what do you think is the direction they want to go? Do they want to also provide the perception component along with the sensor? What is the reason for that?
I guess, maybe I'll draw an analogy with a sort of a different part of the automotive industry that kind of happened maybe a little bit before autonomy. So, if you look at the companies that produce headlights for cars, right? So, I don't know, 20 years ago or so, headlight was kind of a molded component with maybe, 10 parts or so kind of bonded together. It kind of sat on the front of the car. They were generally pretty standard. they all kind of did largely the same thing. And these companies, made a reasonable amount of money, kind of making and selling headlights. It's quite specialist. There's some optics in it that aren't involved in other areas or at least weren't at the time in other areas of automotive. So then the introduction of LED headlights, suddenly you can do so much more with the light when you have effectively a surface mount component where you can direct the light in new ways that you couldn't do before. And what you've seen over the last kind of 10, 15 years is companies really investing in kind of headlight technologies. If you look at night now, you can often tell the brand of a car from its headlights. Audis have a particular look at night. They have the kind of almost like eyebrows, right? These cars are branded on their headlights. They're not a few standard parts bonded together anymore. Now they're kind of 30 something. Some of them have active components to steer the light around. You've got laser headlight. And what you've seen is these headlight manufacturers' revenues have massively increased through that time by integrating these technologies into it. And increasing their technology offering, they've grown their companies. And they're very keen to continue integrating technologies because they've got a good experience of it. It's allowed them to get kind of more of the car real estate. It makes sense for the sensor companies in that respect. If everyone's kind of battling for this autonomy real estate and they all want to get as much of it as possible, it makes sense that the sensor companies would try and push that boundary as far as they possibly can. And it looks like they've been pretty successful in doing that. I guess this is where for example, LiDAR companies, where the diversity really plays into their hands because there's so many different approaches. We talk about redundancy in the sensor suite because different sensors have, different strengths and weaknesses, and you need to create a complete system. Different LiDAR approaches have different strengths and weaknesses. They have, they all work in slightly different ways and therefore produce their data in different ways. And that data should be interpreted according to how it's produced. There's not a standard LiDAR architecture. So it allows the sensor manufacturers to really own the algorithms applied to their data as well. It's interesting that the two exits we've seen so far were, a reverse IPO via SPAC rather than a big acquisition by maybe a tier one. I suspect that's more to do with kind of the global economic situation than anything. But yeah, it's interesting to see kind of where this ends up, whether these LiDAR companies effectively end up becoming like tier ones themselves, selling directly to OEMs, whether some of them get big enough that they could acquire a small tier one and sell to an OEM, or whether they diversify into other markets as well and start acting as, a little bit like some of the big tier twos that don't just serve automotive, they serve many different industries. Yeah, I think it's probably a little early to say, but it would be really interesting to see how that plays out.
Totally. So where do you think the LiDAR companies can diversify? Where do you see the obvious application beyond automotive?
So beyond automotive, I think it's useful for a lot of autonomous systems. I guess some of the classic use cases that people talk about are things like mining. I guess what I've heard from my clients in the last few months is automotive revenues are still going to take a while. An automotive development cycle is many years. So even if you get this OEM order now, it's a long time before it's in cars. And unfortunately, our LiDAR company staff expect to be paid all the way up to that point, not just at the time you start becoming profitable. So there's lots of companies looking at short-term revenue streams. I guess the biggest markets for them, what they're looking for really is the cost of LiDARs at the moment is quite high. They're still pretty expensive. The cost is going down, but it's still fairly high. So typically the most valuable short-term revenue streams for them are use cases where they're not quite as, as cost constrained as the automotive industry. So where, there's capital equipment that's very, very expensive. So the LiDAR adds a bit of extra functionality on top, but isn't a scary price point to the sort of customer. So some of the examples are, mining vehicles. They're kind of hazardous environments. So it makes sense that you wouldn't want to send people down there if you can avoid it. But the cost of mining equipment is really high. LiDAR does not look worryingly expensive to someone who's spending millions of pounds on this enormous vehicle, which is designed to operate in mines. We see lots of work, integrating them into mining vehicles, but also things like drones for mapping down mines. That's also kind of a valuable short-term application. I mean, some of the more interesting ones we've seen recently are kind of smart city applications, monitoring things like traffic accurately. At the moment, in a lot of cases, radar systems are used, but these can become a little bit inaccurate in really stationary traffic when there's kind of almost no velocity. So LiDAR can be useful in these cases. Again, big traffic installations are not cheap things, so the LiDAR price point is not too worrying. Also, some security applications. It's a really good way of monitoring people, which is anonymous. You can't tell who a person is from their LiDAR point cloud signature, fortunately. So I guess one of the things that we've seen has been really interesting in the last kind of 6 months or so is, where you want to monitor kind of social distancing, you want to know where people are, and specifically, you want to accurately measure their distance relative to one another. LiDAR is perfect for that. You don't need to worry about recording people's personal data by taking their image, but you can record pretty accurately the number of people in an area and exactly where they are. This makes it useful for things like security as well.
Fascinating. So, Tom, we are about to enter an era of autonomous vehicle or electric vehicle or connected vehicle. That's going to change our lives, not only in terms of how we commute. There will be new business models, there will be new challenges, there will be new opportunities. So in your opinion, what do you think would be the biggest challenge? And at the same time, on the flip side, what would be the biggest opportunity?
A lot of public opinion now is, when's my autonomous vehicle going to turn up? I can't be bothered to drive. I want to be able to go out and maybe have a few beers and then be able to get home safely, right? But I think that's perhaps a little, that's an attitude that people take before they're asked to actually enter an autonomous vehicle. I think one of the biggest challenges is going to be winning public trust. Getting people to trust autonomous vehicles. For it to become ubiquitous, everyone needs to trust them. So I think we're going to need to tread very carefully in the early stages to win that public trust. And we need to think carefully about their considerations. I think that's going to be one of the biggest challenges of autonomous vehicles. I think, the massive opportunity it creates if that kind of business model can change, and, go from maybe individual car ownership to, shared high utilization vehicles, beyond the environmental benefits, which will be massive. It creates a whole new kind of platform for people to interact. It makes travel more productive. The opportunities there are enormous. It creates this huge new tech platform. I think that's, I'm sure that's what Amazon and Google and all the other tech giants see in it. I think that's what it creates, right? It's not just, don't have to drive your car anymore. It will fundamentally change how people kind of live their lives, and hopefully for the better. What I see the big challenges, and I think see as the upside. The challenge is we really need to win consumer trust. But I think if we do a good job of that, then it will become ubiquitous and it will make everyone's lives better.
Fascinating. The challenges, consumer trust, consumer acceptance. On the other hand, on the flip side, the opportunity is massive platform with enormous new opportunities. Amazing. Tom, it was lovely having you. If you have liked this episode, please feel free to smash the like button, subscribe to our channel. And if you have questions and comment, write in the comment section. Tom, it was lovely having you.
Yeah, it was my pleasure.
Thank you so much. Thank you for watching. See you in the next episode.